Okay, so worksheet 2.9, number 5. Number 5 said you need no more than 3,000 calories a day. So, need no more than 3,000 calories. All of you are looking at your number 5, please. You're making notes as you need to. If you didn't do your homework, you're still taking notes on this. You need no more than 3,000 calories. All right, they tell us that at breakfast, there were 840 calories eaten. At lunch, there were 1,150 calories eaten. We want to know how many calories must you eat at dinner. Okay, so you guys, as you're reading through this, you're reading through any story problem, I want you paying attention to things that are being measured here. Here, all we're measuring is number of calories. So somewhere, there's a total number of calories that you've consumed or that you're going to consume. Here, we know that we want no more than a total of 3,000 calories. That's your whole. So as you're reading through these, look and see, what is it that I am measuring? Here I'm measuring calories. So there must be a total number of calories somewhere. That's that 3,000. All right, so my whole is the total calories. Now I'm going to go back and see what makes up those calories. Well, I have breakfast, I have lunch, and I have dinner. That's basically what makes up the calories. If you're thinking to yourself, I'm going to take the total number of calories and I'm just going to subtract off the breakfast, subtract off the lunch. If that's your immediate thought, you need to stop and say, okay, the number that I'm starting to subtract from, that's your whole. So you're going to write it down as your whole. The pieces that I'm subtracting off, well, those are your parts. So write them down as your parts. You've got to switch in your brain that you have to do parts equal to the whole. So my whole is my total calories. My parts are my calories at breakfast, plus my calories at lunch, plus my calories at dinner. If this was an equation, it would say we want to eat 3,000 calories in a day. These three things added together equal the 3,000 calories. But here they say that we want no more than 3,000 calories. So is that total number of calories a maximum, or is that total number of calories a minimum? Ben, sit up and listen, please. Is that total number of calories a maximum, or is that total number of calories a minimum? Ava? That's a maximum. So when we have a maximum, Ben, when we have a maximum, what does our parts have to be in relation to our maximum? Can they be less than our maximum or more than our maximum? Our parts has to be less than, because it's a maximum. It says no more than. So if it says no more than, can it be equal to as well, Lawrence? Yeah. So there is my game plan. That's the hardest part. Now we're going to literally write our equation or an inequality that mimics that. It's exactly that format. Well, I know that at breakfast, I had 840 calories. At lunch, I had 1,150 calories. At dinner, I had X. They said C. I like to use X. That's just me. Is less than or equal to that 3,000. So questions on writing that. All right, somebody tell me how to solve it now. Alex? Excellent. So I'm just going to go ahead and add that. That's 0,991. Did I do 1,990? Did I do that right, Alex? Plus X is less than or equal to 30. If I didn't, stop me. Now what, sweetie? Excellent. So I get X is less than, okay, that's a 0. I have to borrow. That becomes a 9. That's 10. It's a 1. It's a 0. 1. 1,010. Did I get that right, you guys? Yes? Yeah? Okay. So this is my answer. All right. How do I explain that answer? Someone explain what that answer means. Morgan? Exactly 110? Put your hand up. So this says the number of calories at dinner is less than or equal to 1,010 calories. Is it at least? So is this 110 a maximum based on what this is set up or a minimum? Put your hand down. It's a maximum because all of our calories have to be less than that, right? So state that. Excellent. At dinner you eat no more than, excellent, 1,010 calories. So please take the time to read what that actually says. Remember, you can always, here's a tip for you guys. When you're trying to write that sentence, go back and see how they explained it. If you notice, Morgan, they said no more than in their description. Use that same phrase in your sentence. All of you noticed that. It said no more than 3,000 calories. So don't guess. Just go back and use exactly the same phrase in your sentence. Okay? All right, what else can I do real quick? How about from 210? Jacob? Number 12? Okay. If I look at number 12, I have x divided by 5 is less than negative 4. Is this the one you're talking about, sweetie? Okay. So I'm dividing x by 5. How do I undo that division by 5, Jacob? And what operation am I going to do with the 5 over 1? Yep, I'm multiplying both sides by 5 or 5 over 1 to get rid of that division. I am going to divide out common factors here. I do agree with that. All right, so now I have a 1x on the left. I have negative 20 on the right. Now the question, because this is an inequality, the question is, do I flip the symbol or do I not flip the symbol? So I look to my coefficient. So all of you are paying attention. What is my coefficient here that I'm looking at, Jagger? That 5. Jagger, is that 5 negative or positive? Positive. So do I flip the symbol or no? Excellent. I don't care that that 4 is negative. It's only the number that's with the variable. Does that help you? Awesome. Okay, so get your notes out, please. If you have any other questions, please come see me in study hall. If you need to come see me at lunch, let me know, and I won't leave. All right, so what I need to do is go through a test summary for you. All right, so this is going to be my Chapter 2 test summary. All right, the first thing that we talked about were properties of numbers. The first thing we talked about were properties of numbers. This was commutative property. This was associative property. And the big one was distributive property. You may have to explain any one of these, not more than one, in your own words. All right, you might have to explain the process of the distributive property. If you know how to do it, you can explain it. So I'm thinking explaining these, I'm hoping explaining these aren't that big of a deal, but understand what the commutative property means. It means being able to move the order of numbers around. Dissociative property means grouping them differently. All right, the second thing is simplifying variable expressions. All right, you might have one that looks like this. 5 plus 3 times a quantity of 2x plus 7. That's an example where we might have to use the distributive property. Come on. We might have to use the distributive property, and we might have to combine like terms. You're definitely going to have something like this in there. This is from section 2.3, is that section. So go back into 2.3, kind of practice a couple more. If we don't have very many of them in the chapter review, go back to those, practice a couple more of those. I think we had some of those on a homework quiz. We had one, maybe. Number 3, we were writing and solving equations. All right, this was 2.5 and 2.6 were the sections from this. We had something like x minus 5 is equal to 7. That's an example of one of those. Remember, when you have ones like this, what do you have to do first when you start solving this? When I have subtraction, Hannah? Absolutely. You need to do adding the opposite first. If you don't, it's not that you will get it wrong, but you're not setting yourself up to get it right completely. Adding the opposite can be really helpful. Another one is something like n divided by 3 is equal to 7. Okay? 2x is equal to negative 3. These are all examples of those kinds of equations. But the big thing I also want you to know is there are story problems in this. I would definitely go back to story problems from that section. Those two sections. The last thing we did were inequalities. They're exactly the same as those equations. They're the same story problems. They're the same setup. So practicing those story problems, whether they're with equations or inequalities, they're all going to be the same type. The only difference is like in the one that Suzanne had me do, an equation might say the total number of calories I am going to consume is 3,000. And then I would have the rest of the problem be exactly the same thing. That would be an equation. As opposed to what this one said is no more than 3,000. I set it up exactly the same way, but now it's an inequality with an inequality symbol. But the setup is exactly the same. The process solving is exactly the same. Okay? So when you're practicing these story problems for our equations, you are practicing the same types of story problems for the inequalities. So you're kind of double dipping and practicing more. So if you understand the structure of an equation, you're going to understand the structure of an inequality for story problems. So the last thing was solving and graphing inequalities. Remember, when we're graphing, you have to remember the dot, and you have to remember the shading. And what we're graphing is we're graphing the solution. Remember that. All right, this is 2.9 and 2.10. you will have to look at story problems from here. So I've given you the different sections that you could possibly have story problems in. You are definitely having 2, maybe 3 story problems on this test. But you guys, I am going to try and focus on ones that are from our homework, or ones like ones from our homework. So it is very beneficial for you to spend the time going back into those our sections that you had story problems in from those 4 sections and redoing the actual problems that we had in our homework. Okay? You guys cool? Okay, you guys can go.